Question number 1. Find the probability of drawing 3 an even number with an ordinary 6-faced dice. So here first we will have a recall a 6-faced dice. On a cubic dice you'll be getting a number 1, 2, 3, 4, 5 and 6. So the total number of possible outcomes in a dice which is equals to, so there are 6 numbers, so the total will be 6. So here we need a total number of possible outcomes when a dice is drawn once, so which is we get here, that is 6. Now the first one, you'll have to find the probability of drawing a number 3 or probability of getting a number 3 when a dice is drawn once. So we can see here from the sample space, when a dice is drawn once, a number 3 is only given here 1. So then the probability of getting a number 3 will be number of favorable outcomes, that is 3 only 1, upon the total number of possible outcomes, which is we have here 6, that means 1 by 6. The second one here, probability of getting an even number when a dice is drawn once. So from this sample space you will have to count the number of even numbers. So here 2 is an even number, again 4 also an even number, 6 also an even number. So number of favorable outcomes, which is 1, 2, 3. So we have 3 even numbers divided by total number of possible outcomes, which is we have here 6. Now both are divisible by 3 table, so we can cancel here 3 into 1 times, likewise 3 into 2 times, that is probability of getting an even number, which is equals to half. Now question number 2, find the probability that an odd number turns up in a single throw of a dice. Again here it's a repeated questions only. So when a dice is thrown once, then the sample space are 1, 2, 3, 4, 5 or 6, which means the total number of possible outcomes when a dice is thrown once equals to 6. Now what we need here are favorable outcomes, that is an odd number turns up in a single throw of a dice. Now here odd numbers. Odd number is a number that is not divisible by 2, which means 3 is not divisible by 2, so which is an odd number. Again 2, which is even number. 5, that is an odd number. 6, even number. Likewise here 2, even number. Then 1, which is an odd number. So here you'll have to find the probability that an odd number turns up in a single throw of a dice. So we get here 3 odd numbers, they are 1, 3 and 5. So here total number of possible outcomes, which is 6. Then the probability of getting an odd numbers or that turns an odd number when a dice is thrown once, which is we get here only 3, that is number of favorable outcomes divided by total number of possible outcomes, which is 6. Again it's possible to cancel here, so you can cancel 3 into 1, again here 3 into 2. Now the third one, again here the third one, a dice is thrown once, find the probability of getting an even number, a number greater than 3, a number between 3 and 6. So again here the sample space, total number of possible outcomes when a dice is thrown once, then the total we get here 6. Now the first one, you'll have to find the probability of getting an even number. So here even number, we can see here even number is a number divisible by 2 or multiple of 2. So 1, 2 and 3. So that is number of favorable outcomes 3. Always we divide by the total, which is 6. Again possible to cancel here 3 into 1, 3 into 2. Now sub question number 2, that is you'll have to find the probability of getting a number greater than 3. So which number are greater than 3? Yes, they are 4, 5 and 6, which means how many numbers we are getting? Yes, that is 3. So number of favorable outcomes, that is 3. Always we divide by the total, that is 6. Again possible to cancel here 3 into 1 times, again 3 into 2 times. Now the third one, that is find the probability of getting a number between 3 and 6. So which number falls between 3 and 6? Yes, they are 4 and 5. So how many numbers? Yes, only 2 numbers, which means here the probability will be 2 upon the total, which is 6. Again, possible to cancel here. 2 into 1 times, 2 into 3 times. Question number 4. When 2 coins are tossed simultaneously, find the probability of getting 2 heads, at least 2 heads, and no head. So, when 2 coins are tossed simultaneously, then all the possible outcomes are given here. So, consider a 2 coin, first coin, and the second coin. If you toss these 2 coins, then the possible outcomes when you toss the first coin, then we may get head, if not tail. Likewise, for a second coin also, if you toss here, we may get head, if not tail. Then collect all the possible outcomes when 2 coins are tossed simultaneously. So the first we can take here, head, head. So here, the first one, we may get head, head. If not, again here, we may get here, that is a tail head. That is a tail head. After that, if not, again from here, we can take here, that is a head, tail. That is a head or tail. If not, we may get tail, tail. So, tail, tail. So, when 2 coins are tossed simultaneously, all the possible outcomes or the symbol space are head, head, if not tail, head, if not head, tail, or tail, tail. So now the total number of possible outcomes, which is equals to, therefore here, total number of possible outcomes when a coin is tossed twice, then it will be 1, 2, 3, 4. So which is equals to total number of possible outcome will be 4. So sub question number 1, under that you'll have to find the probability of getting 2 heads. So here you can find out 2 heads. So here head, head, which means these are 2 heads. So how many we are getting? Only 1. So divided by always total number of possible outcome, which is 4. Next, probability of getting at least 2 heads. So at least 2 heads is also similar to this one. So 2 heads other than no. So which is only 1 divided by 4. And the last one here, probability of getting no head, which means without head. So without head means tail, tail, which is we have here 1 divided by 4.